Okay, we are almost done. This page right here has 17 and 18. These are both theorem problems, right? Which means that we are looking at the two new theorems, the mean value theorem and the intermediate value theorem. I'm sorry, the extreme value theorem, and then the old one, which is the intermediate value theorem. But all together, these are the three theorems, and this is a question which checks us on them. So what are we told? F is continuous and differentiable. If you remember, in order for the IVT and the EVT to be eligible, we needed them to be continuous, the function to be continuous. Mean value theorem required continuity on the closed interval and differentiability on the open interval, which we have. So that means all three theorems are in play. Which of the following could be false? All right, so what does A say? A says f prime of C is equal to f of B minus f of A over B minus A for some C between A and B. If this right here, if you recall, this is the conclusion of the mean value theorem. This is true if the function is continuous and differentiable, which it is. So this is okay, because we're looking for the one that's false. This here is true. F prime of C is equal to 0 for some C in between A and B. Well, none of the theorems guarantee zeros. Right? So this one is false. All right? There's no theorem that guarantees the derivative will be equal to 0. That means that these two should be true. What's going on here? F has a minimum value, F has a maximum value. Yeah, that's exactly what the extreme value theorem said. These are both extreme value theorem conclusions. All right, so they're both going to be true as well because we needed the function to be continuous. All right, B is the false answer. 18, once again, we have a continuous function and a differentiable function on the interval from -2 to 1, either closed or open. What else are we told? F of -2 is equal to -5. That's probably important. F of 1 is equal to 4. That's also probably important. Which of the following statements could be false? Okay, so once again, we're getting into our theorems. This one specifically will focus on mean value theorem and intermediate value theorem, and then it touches real quick on the extreme value theorem. All right, let's work from the bottom first, because in the bottom one, that's actually our extreme value theorem. All right, we see f of c is greater than or equal to f of x. That's another way of saying an absolute max. All right, we have a highest y value. This is guaranteed by the extreme value theorem if the function is continuous, which it is. So this is a true statement and therefore not the answer. The other two statements, the other two theorems rather, are what we're going to use for these. We see f of c is 0, f prime of c is 0, f of c is 3, f prime of c is 3. Okay, let's talk about the f's first because that's your intermediate value theorem. Okay, the intermediate value theorem says that we will hit all the values in between the starting value and the ending value as long as the function is continuous. The function is continuous, so that works. So we have -5 to 4. Well, 0 falls in between -5 and 4. So the intermediate value theorem says, yep, that's going to happen. 3 falls in between -5 and 4 as well. So the intermediate value theorem says that will happen as well, which means that one of our derivatives is going to be false. All right, so this goes back to the conclusion of the third and final theorem, the mean value theorem. So mean value theorem is right up here. And remember, it says that the derivative is equal to the average rate of change. So guess what they're looking for us to do here? An average rate of change. Yes. All right, so let's get that done. All right, let me keep that on the screen. So we actually need f of 1 minus f of -2 over 1 minus -2. If we calculate this, we'll know which one of these two statements is true. Will the derivative guarantee to be 0? Will the derivative guarantee to be 3? Well, f of 1 is 4. F of -2 is -5. So we have 4 plus 5 over 1 plus 2, or 9 over 3, which is equal to 3. So this statement right here will be true by the mean value theorem. Right? But 3 is the only number that the mean value theorem guarantees, because we did the average rate of change. The average rate of change did not produce a 0, so this one could be false. The derivative might be 0, but it might not. The mean value theorem only guarantees that the derivative will be 3, because that's what the average rate of change produced.